All right, so this is an exponential equation. Anytime you have a variable in an exponent, an exponential equation and a logarithm equation starts with logarithms in the equation, so exponential equations. The way you solve an exponential is you do logarithms. The way you solve logarithms is you do exponentials. Each one undoes the other. It's not guesswork. If you have, way back in the very beginning when you first started solving equations, if you have x plus 3, it's not guesswork what you need to do. It's you do the opposite. The opposite of addition is subtraction. Well, the opposite of, or the inverse, if you will, the inverse of exponential is logarithm. So if you have exponential, you need to logarithm both sides. And for our purposes, it will suffice to take the natural log of both sides. It turns out any logarithm base will do. Natural log is the simplest because, among other things, that's what your calculator does. So you have to isolate the exponential, log both sides. So we have natural log of the left is equal to natural log of the right. Dr. Guffey used to say, hit it with a log. So hit them both with logs. Whatever you do to the left-hand side, do to the right-hand side. And now we're ready for our properties of logs, because we know natural log of something raised to a power, you may move this exponential, or this exponent down as a coefficient. So apply the property of logarithms. The whole point of this is to get this as a base, not as the exponential. Now, there are a couple ways to solve this, but I think usually the basic way to do this, the most least troublesome way for a lot of students, is to distribute. Our goal here is to solve for x. We're going to solve for x. So distribute 3 times natural log of 2x plus, distribute that in, that's natural log of 2, is equal to the natural log of 28. Do nothing on the right-hand side. Now solve for x, just like you would solve ordinarily. Move the constant across and divide out the coefficients. Subtract the constant across, divide out the coefficients, right? So this is subtract the constant to both sides. So subtract this to the other side of the equation. 3 times natural log of 2 times x is equal to the natural log of 28 minus the natural log of 2. Yeah. And now we're going to solve for x. So divide both sides by 3 log 2. Divide both sides by 3 log 2. And what we generate, let me get rid of this little thing. What we generate is x is equal to this numerator, natural log 28 minus natural log of 2 over 3 natural log of 2. As soon as you get x isolated, this is the exact solution. Anytime you leave the logarithms, or if you leave in the exponentials, or if you leave in pi, or whatever you're dealing with, if you leave in these values, this is the exact solution. We assume all the decimals, this is not being rounded, all the decimals are in here. You may, if you wish, now find a decimal approximation. And I'm going to do that now. I'm going to say that's the natural log of 28 minus the natural log of 2. Whenever you compute this, you should hit equals to get try that again. Natural log of 28 minus the natural log of 2 equals, that gets the numerator, so that's 3.30 something something. And now I'm going to divide that by, and when you do this, everything should be in parentheses. Really the simplest thing, everything here is in parentheses, everything here is in parentheses. Otherwise, the order of operations are going to snare you in a way that you didn't expect it. So open 3 times natural log of 2, close, and I have 1.59 approximately, and that's going to be close enough for our work. So again, let's do that again. I want to compute this value. Open parenthesis, natural log of 28. Now notice that it opens parenthesis. I'm going to close that and then subtract natural log of 2, close. So I have the entire numerator in parenthesis. Divide by, open parenthesis, 3 times natural log of 2, and I get 1. Ooh, I got a different number this time. Let's try that again. I have the natural log of 28 minus natural log of 2, close, and then divide that by open 3 times natural log of 2, close, close, and I have, this is not the right number. I should have, a good thing I checked my work, I should have 1.27 approximately. So be careful, check your work. Actually, what you can do is now you can take this number and put it here, and it should be approximately correct if I take 3 times that plus 1 and 2 raised to that power. So be very careful. Keep your wits about you. That's not the most brutal thing in the world, but practice that a few times and you should be able to have that.